Okay, so imagine this. Your code base. It's like a house, right? And we're talking like gleaming hardwood floors, a chef's kitchen, maybe even one of those fancy Japanese soaking tubs, all the cool features,
Yeah.
all the stuff users are just clamoring for.
Yeah.
But then you start noticing, the plumbing's making these weird noises, and there's like a suspicious draft coming from the attic, and something smells a little off in the basement.
Uh-oh.
It's basically like this dream home that's been built on this like foundation of questionable choices.
Right.
So have you been there? Have you seen this before?
Oh, yeah, all the time.
Yeah. So today we are diving into this, kind of murky depths of debt versus dreams balancing technical debt and feature development.
Hmm.
We're going to figure out how to spot those cracks in the foundation and, more importantly, what to actually do about them, whether you're just starting out in your career or you're the one signing off on, the blueprints for the whole thing.
Absolutely.
So let's get real technical debt. I feel like this is a term that gets thrown around a lot, but what does it actually mean beyond just like messy code?
I think you hit the nail on the head. It's more than just messy code. It's about the long-term consequences of all those shortcuts we take, those we'll fix it later moments
Yeah.
that somehow never seem to happen.
Right.
It's like borrowing time from the future, and eventually that loan comes due, often with hefty interest.
Oof. Yeah, okay. That makes sense. But how do we even know we're taking on technical debt in the first place? Is it always as obvious as, say, a giant function that's longer than my grocery list?
Sometimes it is that blatant,
Really?
but often it's more insidious. Think about those code smells. We all encounter things like duplicated code, long parameter lists, or classes that just try to do too much they might work for now.
Right.
But they're warning signs, little cracks in the foundation
Uh-oh.
that can become major structural issues down the line.
Okay, so we're starting to see those cracks. But let's be honest here. The pressure to ship new features is relentless. How do we balance, keeping the lights on or preventing the metaphorical house from collapsing with actually building those shiny new features everyone wants?
Right, it's a classic tug of war, isn't it?
Yeah.
And the strategies you use can really evolve as you gain experience. So if you're new to a team, don't underestimate the value of a fresh perspective. Maybe there's a way to refactor a small section of code before adding a new feature, make the whole process cleaner and more robust. Just suggest it.
Yeah, just throw it out there.
Absolutely. What's fascinating is how this approach scales up as you progress in your career. So as you move into like a mid-level role, you start to see these patterns in how technical debt accumulates. Maybe you notice that every time you touch a particular module, it triggers a cascade of bugs.
Oh, no.
That's a prime candidate for some strategic refactoring, perhaps using techniques like extract method or introduce parameter object to kind of break down that complexity.
Okay, that makes a lot of sense. But let's say you're the one calling the shots. You're the architect. You're responsible for the entire code base. How do you convince stakeholders that tackling technical debt is worth the investment, especially when there's always pressure to deliver those new features?
You have to speak their language instead of focusing on all the technical details. Frame it as a risk management issue. Show them how technical debt can lead to slower development cycles, increased bug rates, and ultimately unhappy customers.
Yeah, nobody wants that.
No one wants that. One powerful tool here is data visualization. Imagine presenting a graph that shows how the time it takes to implement new features has steadily increased over the past year, correlating with the growth of technical debt. That's a compelling argument for dedicating resources to addressing the underlying issues.
Okay, you've convinced me we need to tackle this debt. But where do we even begin?
Yeah.
It could feel so overwhelming, like trying to eat an elephant one bite at a time.
Right. The key is to start small and celebrate the wins. Even seemingly minor actions can have a ripple effect. Imagine you spend an hour refactoring a tangled mess of code into a well-structured function. Not only is the code more readable and maintainable, but you've also reduced the cognitive load for anyone who needs to work with that code in the future.
Yeah, that's huge. So it's about building momentum, showing everyone that even small steps can make a big difference. That's a much more encouraging way to approach it than feeling like we have to solve everything at once.
Exactly. And remember, as you progress in your career, your contributions to this effort will evolve early on. You might focus on cleaning up your own code, gradually expanding your scope to include larger modules, and eventually leading team-wide refactoring initiatives.
So it's not about reaching some mythical state of zero debt, but about continuous improvement.
Absolutely.
And maybe even a little bit of joy in the process.
There you go.
So imagine a world where new features can be developed quickly and efficiently because the foundation is solid. No more fighting with spaghetti code or fearing every new line you add. What steps can you take today, no matter your experience level, to make that vision a reality? We'd love to hear your thoughts.
Yeah, let us know.
Awesome. Thanks for joining us for this deep dive on technical debt.
My pleasure.